parents and teachers who may be watching. Welcome to Creating Math Ahas for Parents. I'm Dr. Sandy Atkins, Sandy, and in this video, we'll be looking at how your children may be experiencing division in grade 5. Now, for me, division was really long division. That's my clearest memory, was learning the mechanics of getting answers to division problems. But as we looked at in the 5 strands of math proficiency, there's an expectation that your children understand what they're doing, understand the meaning of division, which helps them with word problems they may get. There's also an expectation that they can flexibly work to find answers, that there's a flexibility in procedural fluency, and that fluency comes from understanding. So it's not that your children are learning these different techniques and they pick one to get an answer. That's not the goal. The goal is the understanding, the playfulness of number, and from that comes efficiency. Now, I'll leave a link below in the description for the 5 strands of math proficiency. But the expectation for your 5th grade child is to really understand and use place value to divide, understand related properties, use the relationship of multiplication and division. Think of it as missing factor. There's also an expectation that they will be able to illustrate and explain using equations, using drawings, and the drawings may be equal grouping drawings. They may be rectangular arrays. They may also be using area. So it's where we would know the area and one side, and they're finding the missing side length. So all of these pieces go into finding the go into division, learning division in grade 5. Now, there are 2 meanings that we'll look at today. One is partitioning. It's separating into equal groups. And the other one is sometimes called quotitioning, or measurement division, or pulling off equal groups, same size groups, or same size rows. Okay, so we'll be looking at those. And if you look at the intro to division video that I did, and I'll leave that link in the description, you'll be able to get a little bit more information of how that works across the grades. So I'd like to look at some of these pieces, do some examples for you, let you see how these all play out. Now, we'll be using certain manipulative materials. You may see your child using base 10 materials, or at least see the photos of these, the pictures of these in their work. So what I have here, 100 block, tens, units. I have a smaller version that I'll be using so you can see it easier. But essentially, we're going to be using models for hundreds, tens, and ones. There's also a model available for thousands, which would be a cube, 10 of these. We'll also be looking at some examples with fractions. So your children more than likely will either be using or making a fraction kit. One thing that I point out when I use fraction kits is I do not label mine. That is purposeful. I don't want fractions and fraction kits just be about reading a number on there. This is 1/4. If they aren't sure what this is, they find that 4 of these pieces equal the whole. Therefore, it's going to be called 1/4. So it's embedded practice. It's purposeful. So you may see that they aren't labeled, and you may see these materials, but I hope you also see that they're very purposeful in how we're using them and the meanings that we're hoping your child develops about the different operations and about number. So let me move these off, and we'll take a look at a couple of problems. Let's see here. First problem I'd like to look at is 351 separated into 3 equal groups. Now, do you notice how I just read that? 351 separated into 3 equal groups. Now, when I saw this as a kid, I would have said 351 divided by 3. There's nothing wrong with that. That's fine. The problem is, as we do 351 separated into 3 equal groups, that is starting to use the language of story problems. right? So we're starting to build language of story problems. And that's why it's important for your child to understand the meanings, the models for division. So remember, I said one model is partitioning, separating into equal groups. Another model is quotitioning. Now, this is a model that may be introduced to your child in grade 3 when they're introduced to multiplication division. Now, this as it is a multiplication model. And one thing we want your child to understand is that multiplication and division are inverse operations. And see, if I took 3 groups of the same quantity, I slide it down in, I get the product. If I turn it around, see, looking at that inverse operation, I can separate it into 3 equal groups. Now, we could have your children start with 300, and I can use the 5 tens. Now, notice how I'm not worried about where in relation to the hundreds I'm putting those tens. Mathematically, because the model the way it is, I have that 351. It's okay that the tens are here because they're still worth 10. Now think about how we separate this into 3 equal groups. I can put 100 in each group. I can put a 10 in each group. But now look what I have left. I'm going to have 21 left. And as I look at this, I'm going to have to rethink this as 21 ones to be able to separate the ones into each group. So instead of continuing to use this, I'm just going to draw the related lectures. So let's say I have 300. I'm going to use the squares for the hundreds. I'm going to use lines for tens, just more efficient. And then a dot for the ones. I want to separate this into 3 equal groups. Now, once I separate them into equal groups, the hundreds, I have enough that they go into each group. The tens, as I said, I can put a 10 in each group. Okay. And then I have this left over, 21. So I need to think of 21, 2 tens and 1 1 as equivalent to 21 ones. Now, once I do that, see, I can separate and put 5 in each group. And your children at first may be asked to act this out, especially if they haven't necessarily been modeling it. Earlier grades, you might see them acting it out. And you might be thinking, why are they doing this when they could just learn that algorithm, that long division? Now, again, there could be word problems that we're linking to, but let me show you that long division algorithm. See, I'm going to separate 351 into 3 equal groups. I have 3 hundreds. How many hundreds could I put into each group? I can put 1 into each group. How many of these did I use? I used 3 of them, so I used all of them. I don't have any of those left, but I have 5 tens left. How many can I put into each group? 1. I've used up 3 of them. I still have 2 of them. And I also have a 1. Instead of thinking of this as 2 tens and a 1, I'm going to think of it as 21 ones. How many can I put into each group? 7, 21. Used up all of them. Okay, there's no remainder. See, by doing this, they are modeling what they'll later represent as the long division algorithm, but they'll be able to explain it. It becomes much more than divide, multiply, subtract, drop down. You see, I remembered we learned all kinds of mnemonic devices to remember this mechanics versus visualizing this. So we're using that imagery of what is going on. Now, this equal grouping model, this separating equal groups, makes sense to me when the divisor is a single digit. And it makes sense to me if the divisor is a single digit, whether I'm doing whole number division or I'm doing mixed number division. Now, when I learned division with fractions, we would have gotten this equivalent fraction, which improper it was called at the time, as 21/5, and then we would have multiplied by the reciprocal. And I hear some people say multiply, flip it and multiply, right? But see, think about if I am separating, and I'm going to use a drawing for my strip model, that fraction kit model, instead of actually bringing those out. So let's say I've got 4 holes. Okay. And I'm separating this into fifths. We'll pretend I did that. I apologize for my drawing. So I've got 4 holes and a fifth. See, I want to separate it into 3 equal groups. This work that we did here with whole numbers sets me up to do the same type of work with mixed numbers. Now, what do? I'm going to put a hole in each group. Okay. Apologize for the drawing not being precise, but I hope you get the idea. I've used up those 3 holes. And now I have this hole and this, but I can think of this by cutting it in to 5 equal pieces. And now what can I do? I can put 2 1/5 pieces in each group. Okay, so what is 4 1/5 separated into 3 equal groups? Well, it's 1 2/5. Again, it makes sense to do this type of division, thinking of partitioning, separating into equal groups, using the same model. Now, let's go back to this one. I separated, sorry again about that error in my drawing, but I separated 351 into 3 equal groups. What was one group of this? How much of my whole is this group? And this group, and this group. Do you agree that it's 1/3 of my whole? If I separate into 3 equal groups, 1/3 of that 351 is going to be 117. What's another way to write that? 1/3 of my 351 is equal to 117. Notice the equivalency, but I'm building it from understanding. I could think of it as division, or I could think of it as multiplying by the reciprocal, 1/3 of it. Think back to this one. What part of the whole is this? 1/3. How much is 1/3 of that 4 1/5? Well, we know it's 1 2/5. Same as multiplying by the reciprocal. But I'm not going through extra steps. I can do some of this in my head, right? Separating out. It now takes things that would have been paper and pencil and recalling a procedure to being much more conceptual. Now, I want to look at one more. 2 divided by 3. 2 wholes separate into 3 equal groups. Now, if we use my model again, thinking of that fraction kit work they would have done, if I want to separate 2 into 3 equal groups, well, what can I do? I can separate it 3 parts. I'm going to end up, and you'll see I'm going to draw the whole as a dashed line when I draw what goes in. And then I'm going to cut it and I'll outline the thirds. You'll see different models, but do you see how I'm putting 2 in here, 2 1/3 pieces? I'm going to end up putting 2 1/3 pieces in this next group. 2 1/3 pieces in this last group. So I separated these out. You might see different pieces going. I just circled those, and those. But what is 2 separate into 3 equal groups? What is one of the connections we hope your children make is connecting this line to that symbol, that this is a division symbol, another way to think about it. So we can partition equal groups. This, again, makes a lot of sense when you're doing single-digit divisors. To me, when you get larger than single-digit divisors, it becomes much more cumbersome. It doesn't make sense to keep drawing all those circles. It's not efficient. Now, one of the models your children are learning, beginning in grade 4, I suspect, is an area model for multiplication. And I just want to show you this because we're going to use, as I said, no area in one of the side lengths and think about the missing side length. Now, if you look at this one, see, think about, I've got a rectangle and we're just doing a sketch, so I apologize, it won't be to scale. It's 13 by 24. I'm going to find its area, and your children may learn something where we use what would be expanded form. So I'm going to think of 13 as 10 and 3. And I'm just going to cut this rectangle across. Now, right now, this area is a 10 by 24, and this one is a 3 by 24, the dimensions of the rectangles, right? The area would be 240 square units. This one would be 72 square units. I can play around with that. But now another thing I can do is think of this as 20 and 4. Notice I'm using expanded form. This rectangle's dimensions 10 by 20. This one's 10 by 4. This is 3 by 20, 3 by 4. Now, again, some of you may be thinking, well, why can't they just learn the multiplication algorithm I used? Well, you see what is happening here. If I do this one, I'm going to write it a little bit differently. I'm thinking of 13 by 24 as the same as 10 and 3 times 20 and 4. And some of you may have learned the distributive property, or you might have learned some FOIL, a mnemonic for a certain type of distributive property, expanding it. But notice what I've done. 10 by 20, 10 by 4, 3 by 20, 3 by 4. See, the reason your children are learning this area model for multiplication is it leads to what will be called binomial multiplication later. It is a representation of distributive property. The algorithm we learn does not get us to that distributive property, at least not directly, but this will get us to that standard algorithm. And you'll see that a bit later, okay, in the multiplication video. Now, notice some other things. Do you notice that my product, when I add all of these pieces together, so I have, these would be partial products. I have 200, I have 40, 60, that makes 312. So I have 312. Now notice some things. Notice that this digit matches the last digit of the ones place product. Notice that these are multiples of 10 and ones. We're using expanded form. Those are some important things for your students to notice. And your children in school may be asked to notice and wonder. What do you notice? What do you wonder? It's really helping them build a critical eye, look for patterns, things that they will notice, things that they will wonder about. Now, I want to use this idea. I'll just do one example, and we'll look at 851. Now, in this case, we're going to use the area model. Okay. Now, think about some things you know. One dimension of this rectangle is 23. I have to figure out what the other dimension is. It's missing factor. I'm really thinking about 23 by what is going to give me an area of 851. Now, I could play around with what this could be. Now, for one thing, I know that this has to be a 2-digit number. Because if I did 23 times 100, the first 3-digit number, I'm up to 2,300. That's way too high. So I know this is going to be at least a 2-digit number. If I were to do 23 and think it's in the 20s by 20, or 23 by 30, well, that's going to get me 233, 690. See, that's too small. But I know I'm probably going to have a rectangle where one dimension is 23. This area in here, I'm going to think of the area as 851, and I have to figure out this other dimension. Now, remember what we did up here. We thought of this as expanded form. So here I'm going to think of this as 20 and 3. And one thing this is based on, which they're introduced to in grade 3, is conservation of area. The idea that I can cut area into smaller segments, add those pieces together and get the total area. Many of us who are doing any type of remodeling and you're figuring flooring and what your flooring looks like, you're using that idea all the time. We're just using this multiplication because it's the model that gets distributed property, but also helps us with division. The challenge is what am I going to cut this one into to get this missing piece right here? Now, I could try 40. But if I do 40 here, see, just think about what happens. 40 times 20 is 800. 40 times 30 is 120. I'm already too high. And I showed you up front, 20 was going to be too low. So let's try 30 here. The other thing we could also think about is, what does this value have to end in if 23 goes evenly? Now, if there's a remainder, it's a little tricky, but I'll tell you, I rigged it so this goes evenly. But I suspect the only thing I can multiply 3 by to get a product that ends with 1 in the ones place is going to be 7. But let's continue here. We're going to predict this is 30. So 20 times 30 is 600. 3 30s is 90. Now, your children in grade 4 may be doing a lot of things where they're learning, well, if I know 2 times 3 is 6, what's 23s? What's 2 30s? What's 20 30s? They're looking at patterns for multiplication, getting them ready for this type of thing. This product is much easier to do in my head, so I'm going to use that. Now, as I said, here, I need to have something that ends with a 1, and I'm going to go with 7, because 3 times 7, this area is 21. 27s is 140. Now, these could be considered partial products, but if I have 600 plus 140, I'm at 740 plus 90, right? Plus 100 would be 840, plus 90 would be 830, plus 21. You add those together, you will get 851. So this missing side length, 37. So this is one of those where they're expected to use and explain an area model, but they're doing a lot of that beginning in grade 4, extending it to grade 5. I can use this area model for mixed number multiplication. It works because it's a distributive property representation. I can use it for decimal multiplication. It will work because it's a distributive property. So it's using that property. This is our area model. Okay. So it links to finding patterns and things. Now, I want to show you one other technique that your child may be learning. This is, let's go back to this first problem that we did. And I want us to think about how are ways that we can separate 351. And we're wanting to separate it into values that are easily divisible by 3. Now, if I go with expanded form, so I separate it, notice how these values, the sum is 351. This one's divisible by 3, but this one isn't, nor is this one. So expanded form isn't always the best model for us to use. But how could I separate 351 into multiples of 3? So I could separate into 300. I know 30 is a multiple of 3. Your children may do other parts. I'm going to do 21. The sum of that is 351. And so what I know is 300 separate into 3 equal groups. 30 separate into 3 equal groups, be 10. And 21 separate into 3 equal groups will be 7. Now, if you think back to that very first problem I did, how did we do this? We separated 300 into 3 equal groups, 30 into 3 equal groups, and 21 into 3 equal groups. It's the same idea. These are called partial quotients. And the idea is once I find the partial quotients, the sum of these will be the value. So if I have 351 separated into 3 equal groups, I have the 117, the sum of these. Okay. Now let's do another one. They're looking at ways to separate values into multiples of a given number. Now I can use this also for a problem like this. And again, it's where I'm playing around with multiples that I know, 10s, 20s, repeated doubling. Okay, so if I think about 675 and multiples of 15, well, I've done this enough that I know 300 is a multiple of 15, right? Double 15 is 30. So I can use that. So I'm going to separate this out into 300, 300. And some of you may be going, well, 300 is a multiple of 15, so is 600. Sure, you could separate this many different ways. The important thing for your child to understand is that as long as each of these are multiples of 3 and the sum is equal to your dividend, it'll work. It'll give you the same answer every time. And that's a pattern we want them to notice. Now, I've used up 600. I can go with 60 is a multiple of 3, and I can use 15. Now, just like up here, here are partial quotients I can do, and I'm using equations to represent. I'm separating this one, multiple of 3, 300 divided by 3, 60. What is 675 divided by 15? And notice what I'm really doing is I'm pulling off multiples of 15. This is, I'm dividing it by 3. Oh, you guys, are you all yelling at the screen? Like, what are you doing? Let me try again. I'm sorry. So I could do 300. How many multiples of 15 are in 300? 20. Does this look a little better? I got 3 in my brain from that upper problem. 60 separate into 15. Those 4 of those pulled off 15. And there's 1 multiple of 15. So how many multiples of 15? I'm using quotative division idea. I'm pulling off those multiples. I end up with 45. Okay. So this is using partial quotients. Okay. Now I want to think about one other piece of this pulling off how many are in, a measurement off. Let's look at this problem. Remember when we did 4 1/5 divided by 3? I read that one as 4 1/5 separated into 3 equal groups. Okay. I tend to read this differently. I think of this. Actually, I want to change this problem a little. Let's change this to 2 1/2. I'm going to read this as how many fourths are in 2 1/2. Now, I bet you can picture that already. But if we draw this, here's 2 1/2, and I want to find how many fourths. Now, this is a measurement model. We'll see if I can show you a little bit of it. The idea is I'm just going to show you 1 1/2. Okay. And I have the 1/4 piece. The idea with this, you're picturing, and that's partly why I use these 1-inch by 12-inch strips. The measurement model lets me parallel some things that I'll use with a ruler too. But here I can measure off. I've got 1, 2, 3, 4, 5, 6. So there's 6 fourths in 1 1/2. How many fourths are in 2 1/2? Well, again, I can separate, and you'll see your children maybe draw something like this, and they may write, they may label 1, 2, 3, 4. I've seen it different ways. But you may see drawings like this, and what they're doing is they're measuring off the force in 2 1/2. So how many are there? There's 10. I have 1/4. Now, if you're not sure, you can multiply by the reciprocal and try. You still end up with 10. But I'm thinking of how many fourths do I have 2 1/2? You can think of pizzas if you want. You have 2 1/2 pizzas. How many 1/4 slices can I pass out to folks? That model, that picture may look more like, I don't know, I guess I tend to eat a lot of circular pizzas, right? If I've got 2 1/2, how many 1/4 size slices can I give out? Still 10. So I'm using language that links to word problems. I'm using models and drawings that represent that understanding. Okay. And we're trying to build those connections. Now I want to show you one more, and that's linked to decimal division and how we did decimal division. Okay. Now, I'd like to I'm going to ask you, using that measurement division language, quotitioning language, if I ask you how many 300s are in 1500, I think you would say 5, right? What if I said, how many 30s are in 150? How about how many 3s are in 15? How many 3/10 are in 1 5/10? How many 300ths are in 1500ths? Now, I remember when I was learning decimal division, we were using long division models. And when you saw that decimal point, the divisor, you did a loop and dot idea. You looped it until you didn't have a decimal point in there anymore, so you had to loop this one. And that was my understanding of this. I was about looping and dotting, which isn't the understanding we want for your child. We want them to understand that to find how many 300ths are in 1500ths, I can use an equivalent quotient. Essentially, what we did was we multiplied the divisor and the dividend each by 100. I could do something that looks like this if I wanted to. What could I do? Well, I could multiply both by 100, and this is going to give me the same as 15 divided by 3. See, when we're doing decimal division, that's what we're doing. We're finding an equivalent quotient that removes the decimals from that division up front, at least from the division with the divisor. And I can pull off multiples, I can do everything that we've been doing, but it's about looking for patterns. It's about understanding models and then extending these models from how they're introduced in grade 3 to this, to using it for any whole number division, but also going for mixed number, right? Also going for area models. So it's the flexibility of the models. It's also linking and building the foundation for the long division. So it's not that they won't learn that long division algorithm, but that is a single answer getting technique. And we're expecting your child to know much more to be proficient at math. If this video was helpful, I hope you will give it a thumbs up, like it, subscribe so you turn notifications on so that you know when other videos are coming. If you have children in other grade levels, I hope that you will check out those grade level specific videos. Thanks so much for watching.